Thank you, Christian. Then let's start. I think we want to share our topic of electrification in terms of the purpose of construction machinery. We are tending to trying to find the machine of the future and engineer the machine of the future. Let's go ahead then in the next 60 minutes together. We will have the chance to firstly introduce our company quickly. And next, we are looking into the electrification strategies we are using with different key technologies to design an efficient system. In the end, it should have also enough time for a discussion round. Also, please join the Slido where you can ask questions. In addition, also help me to answer then the right ones. Please just ask questions also during the presentations. Probably we will have time in the end to come along all these questions. And yeah, just scan the link if there is. I hope it works for all. In the end, I can also put a link in the chat to join the Slido if the QR code is not always present. Okay, chat is I think not available for me right now, but I will go on. Probably we have time later on. SUNCAR, as the name claims a little bit, driving renewable energies from the sun to mobile applications. In the end, we are trying to do that with full performance and zero emissions to reduce the emissions we have so far in our environment by also a lot of mobile applications. We are especially focusing the construction side. We have began a little bit with cars and other vehicles and focusing more and more into the machinery. But as I also have my own experience back in the years 2010, I need to say that our claim is always to deliver full performance. My first experience was back in the years of my student times, where we converted a Lotus Evora, a sports car with a combustion engine of around 300 kilowatts of power, to an electric vehicles, which has the potential to compete the Tesla Model Roadster at this time. That has been a big ambition for myself, that we can that the technology is already here to drive full performance on such vehicles and machines, because there is also other vehicles out there, also in these years, where there is always big boundary conditions about the performance, about the range, and more and more such topics where you just need to be a green head with full commitment to rechange the world to a greener environment. But then I think in the meanwhile, it's getting more mainstream because also it enables great performance. And I think with this great performance of machines and this full performance, also the zero emissions applications can take over for the future. We are doing our work together with a strong team of a lot of engineers, also a lot of engineers from DTH Zurich. We have been founded throughout a project at the ETH, and a lot of employees has also background into these years, and also our team leaders, as Martin, Leandro, and Andreas has joined me on our journey between the foundation of the company until 2015, where we work together at ETH on different projects. We are working in 2 different locations. That's on one hand side our head office in Oberburen and our main R&D office with all the engineers and the workshop facilities for prototypes near Zurich in Schlieren. We're doing this kind of activities with a team of around 50 engineers right now, and focusing definitely activities in the construction machines, utility vehicles and municipal vehicles. We have seen the automotive industry and the on-highway segment also with truck and buses going already their own direction and a very steep path in development phase. Therefore, we are focusing in the less approached topics where more engineering work has also been needed to electrify different machineries. We are focusing our business units in 3 different segments. One is focusing into engineering of different projects. On the other hand, we have also some product department owned SUNCAR labeled and branded products. And in the end, we sum it up with, I think, one of the most important topic at ours is that we are not only deliver some prototype machines where you can put it on your next booth, on the next big fair. Otherwise, we are having big ambitions that our work is also kind of renewable, and we are doing it not only for once, that it can be multiplied in the future by different OEMs which are manufacturing these machines and vehicles. Therefore, we are also helping in the startup phases, building first machines with our service department. In terms of electrification, we have our electrification strategy normally starts at doing feasibility studies, where we analyze different parameters on economical purposes, but also environmental purposes, to analyze also the operation time, the charging possibilities of each applications before doing a prototype development. That is in the end a building of a first machine that could be performed in-house in our workshop, but dependent on the machine size, as this huge drilling rig has not fitted in our building. We are working together with the customer itself and building also the first prototypes at their workshop and offices. Nevertheless, after building a first prototype, the story normally not ends for SUNCAR. We are trying to help the different manufacturers to go into a series production. Therefore, normally next phase in development is to build a 0 series fleet of 5, 10, 20 machines, depending on customer needs. To help this transition from prototype into series, there is a lot of competences needed, especially in high voltage architecture, as we are normally using above 60 volt DC, you're facing more regulations in terms of safety. Therefore, we are definitely helping these different companies also to go and on an operational point of view in these directions to enable their service technicians with high voltage competence, but also helping the workshop workers, sometimes also the sales department to understand electric mobility, electric vehicles. In our product department, we are focusing on electrifications and automation topics. On one hand side, we are doing energy distribution and DC fast charging units, which is a lot of customization work for different OEMs. And we are doing also automation systems, especially for excavators, where we looking into making the operation of a machines even more efficient. I think it's a very important topic where we had also in these presentations today, where automations and not only electrifications can improve overall efficiency of a machine. I think that's also SUNCAR's strategy for the future. If electrification has highly be developed also by the OEMs itself, we are definitely seeing a lot of efficiency gains in automation system. Therefore, starting with first projects also on these topics. And nevertheless, charging is a topic where all electrifications applications will meet somehow. Normally, the machines only will work for a day, for a couple of hours, for a couple of 100 kilometers at the vehicle, and the next thing which needs to smoothly work is the charging. And I think the machine, my claim is always the machine is as good as the charging infrastructure around. Therefore, I think also in SUNCAR's purpose, we're looking into innovation into charging possibilities to ensure the overall customer satisfaction with their experience of using an electric machines in combinations with suitable charging infrastructure. As in our engineering department, we are doing a lot of different stuff, but in the end, we are mechanical, electrical, and system engineers, bringing all competences together to build up a machine, to build up an electric machine, to help also with documentations and certifications of a sub-assembly, or even also the full machine, to bring it in operations and being allowed to making field tests with third-party customers. We think it's time to realize the ideas, the dreams come through. I think we have good references in our past where we had also big companies, big names approaching SUNCAR with the ambitions to do machines where their pre-development team was not able to make that in time for a next big event, big milestone they had in mind to ensure their strategy of going green. Therefore, we're very sure that a lot of these dreams can be realized at this moment of time. There's a lot of components available which ensures the possibility of make it happen. The lithium-ion battery is one of it. I think it has evolved in the last 10 years where we are performing projects already in a very huge way that it's a lot of more energy on the same volume available, getting more dense in energy density, in performance density, but also looking into the price. I think we're all hoping in this industry, beside the automotive segment, that the price will also be more comparable than the automotive is purchasing their batteries. But in the end, I think on the long term, we know the battery prices will go down, and also the purchasing possibilities of having electric machines in the portfolio of any contractor out there getting more and more real. And in the end, I think the technologies of electric motors and inverters, power electronics, what is also needed for such machines is already here. There is existing solutions for electric motors in these sizes where mining applications can be powered with electric motors and with megawatt power of of the power requirements, which are huge. Therefore, we see the full range is available where these mobile applications can be electrified. Looking a little bit back onto our scope of making electric construction machines happen, I think here's a summary of a lot of market innovations. We have worked together with different big names to electrify their machinery, and a lot of these applications will be also going into SOP of production at the manufacturer at the next Bauma, which is the biggest event for construction machines in April next year, 2025. To step into our technologies where we are using to electrify these machines, I think I will present it belonging a reference. We have as an 8.5-ton excavator where we developed together with the German dealer of Hitachi machines. In the end, we are cooperating together also with Hitachi on these excavator developments for the future. In the end, a pre-series of over 100 machines has been released over the last 2 years into the market, the mainly Scandinavian market. Also, the Netherlands has a rising market share of these machines, but in the end, it's appropriate machines for inner cities applications where normally also recharging of the machines is possible. We have started to investigate on voltage level for different applications. In the end, that's a rough estimate where we say over 150 kilowatts of average consumption as a machines, or over 300 kilowatt hours of battery installed. We definitely will go into 750 volt DC architecture. In the end, we see a strong phase out also for the off-highway segment of the 400 volt system architecture, which is based on a lot of automotive applications where we see a big trend going into higher voltages to ensure also quick recharging time. In such a system, we're using different batteries from different manufacturers which are out there, and normally in Europe. They're making the batteries out of cells coming mainly from Asia, NMC technology, but in future also LFP is definitely a trend we are facing to go into different cell chemistries, which are definitely also driven by the Asian manufacturers. We see there is a lot of challenges in combinations with a battery system. You're needing to look into temperature control of these applications. You're needing also with the parallel connections with multiple batteries. There is a lot of challenges into combinations with the battery management system to ensure that the machine is able to run also with a battery which has any problem. Then if you have multiple batteries installed in parallel operations, this battery can be reconnected automatically as an hot sync feature, for example, to synchronize it again on the high voltage bus if the battery is free of any failure again. But we're seeing a big need of having high redundancy and the best uptime into these applications where we are trying to engineer our solutions. In the end, the full system consists also on additional units as a high voltage distribution units. You're having also safety measures as insulation monitoring, DC converters, chargers. In the end, I think for our purpose, we are trying to ensure the customer a new approach into an electrified system, because I think comparing it to a diesel or a combustion driveline with a diesel engine, for example, it is not only consisting out of a diesel engine. In the end, the drive and combustion driveline for construction machinery consists also of an hydraulic power takeoff, an additional drive line normally in such a vehicle to drive also an hydraulic system. You're having in addition also an alternator installed on the same drive shaft to have your 24 or 12 volt system equipped, where it needs to be installed a DC-DC converter. There is also in addition a fan, which is for the cooling of the full system already installed. There is a harness and an engine controller. And in our perspective, that's also needed to speed up the process of electrifications. There is some system needed that the different manufacturers out there can find a fast way into the electrification of their machines. And ensuring these systems not only consists on one brand, because there is multiple suppliers out there for different purposes, and we're trying to find the best solutions for every specific applications, and looking into the eye or looking as in a view of a customer to electrify their machines. On top of any of these systems, thermal management is a very crucial part of an electrified machine, because there is a lot of inefficiencies which are possible, because for example, a cabin in the construction machines has very bad insulation. Normally there is a lot of energy loss throughout the cabin, which is a lot of glass without big insulations. The drivers are used to open up the door and talk with their colleagues on a construction site. There is always the heater on or the cooler on to ensure there is a little bit warm or cold airflow into the cabin, but that definitely is not in favor of a battery capacity, where there is a lot of energy demand from a cabin, from regulating the operator cabin's temperature. Therefore, we are trying to reduce this energy amount as much as possible and trying to install heat pump systems in these applications. And we think it's very important to use different heat or cool liquids inside the machines to combine this or share this temperature levels with other circuits, because we're having at least 3 to 4 circuits also in liquid cooling. The cabin will have a different temperature request than the battery, and that's again a different temperature request as the power electronics, which can go up to 60 or even 80 degrees DC, 80 degrees Celsius. In the end, that's giving a more sophisticated challenge into the thermal management of such machines. We're seeing a lot of potentials of reducing efficiency, improving efficiency, and reducing losses. And nevertheless, to drive the machine, there is also a powertrain needed. We're seeing different technologies out there, and we have in mind for a lot of hydraulic applications that should be operated without any gearboxes in between. There is an axial flux technology available for having high torques on a small volume or even small diameters possible, but in the end, axial flux, the torque is rising with the diameter of the motor instead of the length of the motor. In most applications, it is a very appropriate solutions to ensure a lot of continuous and peak torque for an hydraulic circuit. in the end, this system can be installed in the back of excavator to drive fully electric, and that's based on a diesel machine and kind of kit to ensuring both technologies, combustions and battery electric system will be enabled in a current model of an manufacturer out there. Looking a little bit more into the future, I think it's time to use the Slido if you want to answer the first questions, to look into the future of ensuring which technology will enable the future of an electric machines. We're seeing there is different approaches with different level of optimization happening to ensure highest efficiency. In the first place, we started in the most project with just an electro-hydraulic approach. That's, in easy words, pulling out the diesel engine and installing an electric engine on top. But we think there is more to gain. We're seeing the next level should be with an optimized electro-hydraulic approach, where some rotationary drives can be electrified directly to use the energy without the losses of an hydraulic system. But even then, also optimize the hydraulic system, then some functions can already recuperate energy with a electro-hydraulic circuit. I will explain a little bit more on these applications on the wheeled base excavators. An even more futuristic approach would be our level 3 with a direct electric drives, where we install no hydraulics anymore and install linear actuators for all linear drives, and all rotatory drives are also directly with electric engines. That will multiply the numbers of inverters and motors quite a lot into the machines, and also probably influence the costs. Therefore, I think I would be interested about your opinion, where we will be 2030 to electrify these machines. Which level should be or will be already developed at this point of time and will be helping the industry to go green. I will share the results at the end in the discussion round. Here is a little bit more detail. I explained a little bit the approach already on our electric 8.5 ton machines. That's standard level 1 electrifications for us. We talked about the challenges. I think here is additional some specs of the machines, but we're seeing definitely that the green parts on the machine that are the batteries, and it consumes probably 80% of the volume of this back assembly, electrified assembly. That ensures in the full power mode at least 4 hours of operations. In normal power consumptions, we ensure 6 to 7 hours, and we are ensuring definitely with a recharging cycle over lunchtime that the machine can be operated in a full workday, also on the full loads. But nevertheless, I think a lot of approaches are that this recharging is definitely something which is additional work or also time required, which reduces the operational costs or the benefit of driving electric machines. Therefore, it's a lot of approaches will go into the direction that 8 hours can be ensured without any fast charging cycles. To enable that, we are definitely needing to install more batteries, which getting challenging if not the battery technologies will ensure a double capacity in the same volume in the next years. Otherwise, we think it's better to probably approach to make the machine more efficient. And we are trying to allocate all these field data of our machines with our remote system, where we install on every of these more than 400 machines out in the field so far, and consume or sample a lot of data. We're trying to make also our approaches to find the appropriate way which driveline can be electrified, where is the efficiency potential to make the machines more efficient. And looking especially to a wheeled excavator, it's in the first place very dependent on the application itself. But nevertheless, we think there is definitely some approaches where we face in the project right now to make the first 2 machines present in this year of time, where a lot of functions getting direct electric. Here also the traction drive will be with an electric motor equipped to reduce the hydraulic losses. And I think it's also, in addition, we are electrifying the next rotatory drive, the slewing of an excavator, the turning, where also energy can be recuperated during operations, where the machines turn back and forth. That technology is already a little bit proven by the industry on bigger machines, where the first hybrid excavators has been released, I think, more than 10 years ago, where the slewing drive has been electrified to probably couple that with supercapacitors or even 48-volt systems. Here it's also a high voltage system architecture, where we ensure the energy will be directly goes back to the high voltage battery system. In addition, we electrify also the boom drive with a new type of electrohydraulic linear drive. We have a cooperation partner here in Switzerland, which ensuring that technology to work, to test and improve. And we are aiming for an energy improvement of 35%. We see in the end, it's a lot of potentials on these idling losses, where the machines making some breaks, or having pauses in operations, where the energy can be reduced to nearly zero, decoupling these losses of the throttling. And we are also trying to optimize the hydraulic system. In the end, there is so many functions on the excavator. You're still needing hydraulics in our mind, but we think there is these big consumers, these highest energy demand consumers, where these new technologies of having linear hydraulic drives implemented and recuperating energies, if the boom of an excavator is lowered, it not need to be as a standard hydraulic system that you need to push back. You need to work against the pressure to ensure the safety of the boom. You also need to push down consuming energy that need to be rechanged, that the potential energy of having some weights in the air need to be recuperated, driving down the boom, and therefore trying to ensure that this energy is not wasted. In terms of different challenges we're facing, there is definitely the dimensional challenges of having space constraints, which need to be equipped with an electric motor, which is definitely bigger than a hydraulic driveline. Therefore, there's a lot of topics in terms of dimensioning of space constraints, but also in terms of safety. I think the hydraulics ensures a lot of safety mechanism and safety features that the machines operate in a safe conditions without functional safety in terms of software. Therefore, we are facing definitely also new software approaches to ensure this safety in electric machines. We already have estimated some energy or efficiency improvements. I think it's crazy how much energy can be recuperated and saved by the boom actuator, that we are seeing approximately 75% of energy can be saved throughout the operations of this linear hydraulic drive, to ensure that this energy is not always consumed but also stored. And in differentiations, we're having also on the slew an average of around 40% energy recuperation potential for a tick and dump cycle, or on traction drive, it's still very dependent on the applications, how much the machine will drive. But we're seeing definitely also 30% of energy saved throughout the transport in public roads. To being most open into future, we think we have also worked together again with the ETH Zurich to ensure that our company is looking also still into futuristic approaches. Therefore, we started to convert a 2.5-ton excavator to make that also equipped with the newest technologies, to ensure also that AR technologies meets up in construction machines, but also installing electrical linear actuators. That has been run by a student team at ETH, where SUNCAR is still doing the project lead. We're having also found a lot of technical challenges to ensure that these actuators can be fitted and also safety can be ensured. It's a lot of topics as visibility, which have been reduced, and also working performance, because you will install a lot of weight into the full system. Therefore, ensuring these topics and also vibration and shocks is definitely a challenge. We see there is still room for improvement also on supplier's hand, but we are definitely seeing great results looking into the different efficiencies. In the first place, on this level 1 electrification, we're improving already the efficiency from a combustion driveline, probably where 40% of energy is used. We are nearly doubling up the efficiency just starting into these level 1 electrifications. We are interested to finding next results for this level 2 on the wheeled excavator, but in the end, we're having already some first results on the direct electric, where we see again big potential of efficiency improvement, that we are using in the end overall more than 64% of energy. We're thinking also, as mentioned in the first place, a lot of efficiency improvements in terms of ensuring the full experience to operate the machine efficient. Therefore, we're trying to face the AR technologies to help the operator to have additional information present, how to operate the machines more efficient, ensuring that he only digs as much as needed, therefore ensuring in the end an efficient operation. Exactly. And there is a short video of this machine has been built by the student team. Looking a little bit to the time, I think I skipped that. That video will also be present online afterwards. And I go to my closing words for these presentations, where I see that the electrification is definitely a game changer for our industry. And I think it's our game changer as SUNCAR.
Good. Thank you very much, Stefan, for the insight, for the presentation. I don't know if you will look at Slido, if there's already feedback. Otherwise, I would say, as usual, you write question in the chat, or you raise your hands if you want to ask questions directly to Stefan Schneider and SUNCAR. So maybe there is a first question from Andreas Fuchs. So I open the microphone for him. Yes, you can unmute and then you can ask a question, Andreas. You look still muted.
What is an inversion of an energy vector? On one of the slides, I was just wondering.
That's getting, I think, a real technical, but in the end, the energy vectors is coming from a 4-quadrant hydraulic system where you have different possibilities to ensure where the energy flows. Because you have on an excavator arm, then these 4 quadrants and on a hydraulics, therefore inverting these energy vectors to ensure recuperation potential. But I think that's a separate topic to discuss.
This would mean that when the boom goes down, you recuperate energy, which
Yes.
you can't with hydraulics, basically.
Exactly, yeah.
Okay, thank you much. Impressive.
Yes, well, interesting topics, and I think here I have some questions like, do you see trends in electrifying in the construction or for construction machines towards novel power electronics like SiC or GaN? And what is about the batteries? You were not mentioning much about battery chemistries. Do you see also strong trends towards lithium iron phosphate batteries, like what we see in the EV market to cut the costs?
Yes, I think cutting the cost is probably very relevant, besides the fact that still energy density is one of the most important factor where we see which battery suiting the applications. But in the end, summing it up, I think in the first place, dimensions, because it's not standardized yet, it's a key factor where the different solutions suits or not suiting the applications. There is still not multiple solutions out there where it can be replaced or substituted. Therefore, we see some trends ongoing into LFP, definitely. But in the end, in the first place, it's not the first boundary conditions we're having in these projects. I think to ensure the energy density and the dimensions, and then there should be a solutions which is on good quality. I think that's definitely our challenge, to find battery suppliers which ensures also on higher volumes, high enough quality in terms of making the battery as a system.
But there, I think LFP show potential of being very endurant, having a good aging behavior. the first question was about power electronics. So do you see a push towards silicon carbide or gallium nitride? What do you see the trends in power electronics?
For our purpose of work, it's definitely not the point where we see the most crucial discussions, which this last remaining percentage has been possible to improve. I think overall we're seeing so many different challenges inside the machine architecture, where it is a nice to have feature if the motor is driving on the right RPM to ensuring combinations with the power electronics the best operation point. But there is so much variations in the operation point into how to operate the machine that the machine is overall efficient. We're not focusing our decisions on a supplier on the power electronics to these technologies of silicon carbide. We're trying to ensure that the machine overall efficiency is better than what this improvement will be as the next step, for example.
Okay, that's interesting, because I think everything what you lose you can save on the battery side, and as you said, the battery energy density is still one of the key criteria. It would make sense to the more efficiency you have on the tool, the smaller can be the battery, or the less energy density you need on the battery. So I think this. Yeah, but it's interesting. Well, let's have a look if there are other questions from the audience here. For the time being, I don't see any question or raised hand, so please write in the chat or something if you have questions to ask. I don't see so. So then I would suggest, well, I could still bother you with many questions, but I don't know if it's that interesting for the audience. Then I would say, let's stop the webinar here, and hope to see you then in August for Sphere Energy. So one more thanks for everybody for being here. Please come to the Swiss Battery Days, the iBAT annual conference, and hope to see you at the next webinar in August. Have a good summer and see you in August.